Today I am Geraldine Manda, BSc 4B. In this video, I am going to use Mida Civil software in modeling a truss bridge. First thing you have to do is to import AutoCAD file in Mida software. In order to import the file, just click the logo, import, and then click AutoCAD file and browse the file. Select the layers, which are vertical, top chord, bottom chord, cross girder, diagonal, type top horizontal, bracing, and stringer. And then uncheck intersect frame elements. And then click OK. Steps is to click node or element tab. And then change parameter and then double click the diagonals. In trim menu, click element and then choose element type. And then the mode must be from general beam to truss. And then click apply. Just repeat the steps for bracing. Just double click bracing, select the element type, and then the mode is from general beam to truss, and then click apply. Steps is setting up the material property. In order to do so, click properties, and then material properties, and then click the add button. Select the type of design, which is steel. Choose a standard of ASTM-S and then DB, which is A36, and then click OK. After that, let's edit the section properties. Just click the section properties under Properties tab and then click the Add button. Then select a section. I selected I section. Then insert the name, which is vertical, and then click user and insert these dimensions. And then change the offset. It must be center to center, and then click the apply. Repeat the said steps in cross girder, diagonals, top horizontal, and stringers. After editing the section properties, double click any of the structure group, and then go to Works and drag and drop the said structure group to the model. For example, I first double click the structure group of vertical, and then the vertical became red, and then in Works, I drag and drop the vertical to the model. I repeated the steps until everything in structure group is drag and drop to the model. Next steps is to edit the boundary. Click the boundary tab, define support, and then select this node. After that, check all the dx, dy, and dz, and then apply. And then, after that, select this node. And for this node, just select dx and dz, and then apply. And for this node, just apply dy and dz. And for the last node, just apply dz. After that, click display, this blue screen, and then click element and activate local direction, and then click apply. After that, click the boundary tab, and then click beam and release, and then double click vertical and click pinned, and then apply. And then click the cross girder, right click in order to activate, just click active, and then click top view, select the upper parts, the upper the upper end elements only, and then click Fix Pin and then Apply. And for the lower end elements, click Pin, Fix, then Apply. After that, we are going to activate the top horizontal. And for top horizontal, first click the upper end elements and then click Fix Pin. After applying the fixed pin to the upper elements, select the lower elements and then apply pinned fix. Let's move on to static load cases. Click the Load tab, select Static Loads, and then double-click Static Load Cases. After that, add the name. Choose the type of load, which is dead load of component and attachment, close in open parentheses DC, and then click the Add button. After that, repeat the steps for wearing surface, barrier load, and slab load. Next steps is to click the Load tab, Static Loads, and click Self-Weight. And then in the trip menu, select Self-Weight, and you can see XYZ under the trip menu. Put the value 0 for X, 0 for Y, and -1 for Z, and then click the Add button. The element of beam load, just click Element under Load tab, and then select the stringer. Just right-click in order to activate it, and then select the exterior stringers, select Wearing Surface under Load, and for the direction, click Global Z, and then insert -5.775 kilonewton per meter in the value under relative value, and then apply. After that, select the interior stringers. Again, it is for wearing surface. Direction is still global Z, and for relative value, change it to -6.6 kilonewton per meter, and then click Apply. After that, activate bottom chord, and then click Select All. Click the load case name, choose barrier, and then direction is still global Z, and insert relative value of -0.9424 kilonewton per meter, and then click Apply. After that, let's move on to moving load. It is still under Load tab, and then click Moving Load. Click Moving Load. Choose AASHTO LRFD. Click Traffic Line Lanes, and then insert the data. Lane name, insert lane 1, eccentricity of -4.7, and then selection by 2 points. Just select it on the model, and then click OK. Repeat the same step for lane number 2. However, change the eccentricity into -8.8 meter, and then selection by 2 points again, and then click OK. At under moving load, click Vehicle, and then add Standard. Type, click HL93TRK, and for dynamic load allowance, insert 6.33%. and then click OK. Moving load again, click Moving Load Cases, and then insert load case name of MV, and then click Add, and then choose the vehicle case, choose HL93TRK, and then insert the minimum number of loaded lanes, which is 1, and the maximum number of loaded lanes is quantity of 2. After that, select lane 1 and lane 2, and then click OK. After doing all of that, click Perform Analysis or simply click F5. Once the analysis is done performing, the message window will tell you if your analysis has been successful. In my case, the analysis has been successful. So let's move on to results. Click the Result tab, click Reactions, and then choose the desired load or load combination. Click Self-Weight, and then check the values and legend. And then after that, just click the Apply button. And this is what you can see in your model after clicking the Apply button. After that, again, under Results tab, click Forces, and then Beam Diagrams. Choose the desired load, which is again self-weight. Select MY, and then check Contour and Legend under Type of Display, and then click the Apply button. This is what your model is supposed to be after doing the said steps. After that, under Results tab, click Forces and Thrust Forces. Again, self-weight, and then check Contour and Legend, and then Apply. And this is what will the model look like after clicking Apply button. After that, under Results tab, click the Moving Tracer, and then Beam Forces or Moment. Insert 257 in key element, and then check Contour Legend and apply loads under Type of Display, and then Apply. After that, click Results tab, and then click Results Table. Under Results Table, click Reaction, and then check the desired load, which is self-weight again, and then click OK. After that, click Load Combination, click Still Design, just right after General, and then click Auto Generation, and check Seismic Load Combination. And then after that, click Add, and then OK. And that's the end of load combination. And next steps is to check the steel code. In order to do so, click the Design tab. Under Design tab, click AASHTO LRFD12, close and open parentheses, US. Click Steel Design, and then click Steel Code Check. After that, a table will appear on your screen, and then click Graphic. After clicking Graphic, this is what you can see in your monitor. After that, again, click any member or section, and then click Change. After clicking Change, Click the Search Satisfied section, and then you can see the list of suggested sections. Click Still Design and click Still Optimal Design. After clicking the Still Optimal Design, click the Select All button and then click the Design and Analysis. And then after that, you can see the suggested section for optimum design. And that's all what I did in modeling a truss bridge under Midas Civil software. Thank you for watching.